I need to figure out how to use this, so maybe next time we'll do that. So let's start with the introduction to data mining. And I always use this nice cartoon. How many of you are familiar with, or you occasionally look at Dilbert cartoons? All right, they are interesting and funny, and they are enjoyable. So if you sign up every day, you can see one. All right, and occasionally you can use one of them. Okay, let's see. Okay, we are. Okay, so we will start with what is data. And of course, everybody has been using data. Everybody understands what is data. So in a simple way, a data is nothing but a collection of observations or a set of facts or measurements. And of course, when you're talking of data, basically you are interested in certain objects, certain processes, or certain phenomena. So you are looking at observations, measurements related to that object or phenomena or process. So that's what we mean by data. And here is a nice example of explaining what we mean by data. You go to the grocery store, go to Kroger or any other store of your choice. And what happens is that you pick up items and then you come out, and at the checkout counter, of course, our checkout counters don't look as good or as high tech as this one looks, but you do have checkout counters where you scan items, and at the end of your scanning and all that, the system will generate a receipt. That basically you can say is the data, because it has recorded all the information, what you bought, how much you paid, and things like that. All right. Now let's move on to the next aspect. That is, from data, what we do is we extract information. So what is information? Simply said, information is nothing but it's processed data. Data that has gone through some kind of process. All right. And here is an example at the bottom of the slide. So what we are plotting here is the same store sales. So the central office at Kroger is collecting all the information, all the sales from different stores. And at some point they decide, okay, let's aggregate all that data and convert into information. So in this case, they are basically using data to get information, which is telling them what are the same store sales over different periods of times, with fuel, without fuel. That is what this plots. All right. The important thing to remember here is that while data is fixed, one can get a variety of information out of it. In this particular case, we were looking at, same store sales. That was the information. But you might want to compare stores in different geographical regions and see whether the sales have gone up or they've gone down, or what is the trend of the sales in different geographical regions. So again, that is information, but that information is going to come out from the same data. So data is basic observations, basic measurements. Information is something you do to the data so that it takes a new shape, new form. And of course, the new shape or new form is supposed to be more useful, more relevant for a task at hand. All right. So that's what we have. Now, next. Knowledge. So basically, you can see we are starting from data, going to information, and now we are basically looking at all this information and seeing whether we can convert some of it into knowledge. All right. So knowledge is nothing but patterns of relationships in data and information that show a high degree of certainty. All of you have done online shopping. All of you have gone to Amazon as well as to many other websites. And for example, if you are searching for a book or something, you go to Amazon, you type in the names, and basically they will show you, what that book is and all that. But at the same time, they're going to show you something like this. That is, people who bought that book also bought these books, or a couple of other things they will suggest or recommend. All right. So that is what the knowledge has been gained by whosoever is running that web service by looking at the data that they have through the buying habits of people. So data mining is basically concerned about starting with data, how do we convert that data into knowledge of this form or this nature, so that once you have this knowledge, you can use it for a variety of applications, for a variety of objectives, for a variety of goals. Of course, ultimately, the goal is to make more money. So that's basically what you can do by saying, okay, people are buying these things together. Maybe we can give them a slight discount to encourage them to buy more and things like that. All right. So that is really what the knowledge is. All right. So what is data mining? So data mining is nothing but essentially a process of data-driven extraction of not so obvious, but useful information from large databases. The entire process is interactive as well as iterative. And of course, there are a number of different names that people use to convey the same concept as I illustrated here for data mining. That is, sometimes people call it knowledge discovery in databases. That was the term that people used when this whole field kind of got a start in late 80s or early 90s. All right. People also call it knowledge extraction, data or pattern analysis, and some related terms are data analytics, business intelligence, et cetera, with some minor variations. All right. And of course, if you look at the whole process of data mining, you have a lot of a collection of data, and from that data, you are trying to extract some useful knowledge. And of course, this knowledge typically is extracted in the form of models. So basically, data mining in some sense is an application of machine learning for business applications. Okay, that's what it is. Any question, anytime anybody has, let me know. All right. How about the people in the listening outside? Are you guys able to hear me well?
Yes, Professor, we can hear you well.
Yes.
And obviously, of course, this slide was made many years ago. But since then, you can see that some of the terms related to data mining, at that time, data mining was the term people were using. Nowadays, that's not the term a lot of people use. All right. Instead of that, it's become data science or machine learning and things of that nature. But essentially, all these fields are doing almost very similar things. And if you look into different concepts, different techniques, they all boil down to this, more or less the same thing. All right. So why data mining or why machine learning has become so hot, or why data science has become so hot? The primary reason is that there is lots and lots and lots of data that is being collected through a variety of means. There are all kinds of sensors out there. People are using smartphones for all kinds of activities, where there are companies that are capturing all of your movement, all of your mouse clicks and everything. All right. Outside also, all the credit card purchases, all the online shopping, everything that you do, it's all being captured, being used for building models. So essentially, there is a data glut. All kinds of things are happening. And of course, memory has become very cheap. Communication has become very cheap. So all these things together have given rise to a situation where doesn't cost much to capture data, to store it, to manipulate it, to massage it, and to employ the models so that you can basically use them for all kinds of things that you want to do. And of course, you have seen there are companies that are willing to give you free this, free that, so that they can capture some of the things, some of your activities, and sell those activities. So you can get a free lemonade, but they are going to capture your information and sell it to whoever is willing to pay for it. This is an old cover from Times Magazine several years ago, which basically talked about your data for sale. Of course, since then, what has happened is that people have realized all this data is being sold. So there have been some progress on the privacy fund, and also progress in terms of how much of your data you are going to let some websites capture and things like that. All right, but still there is a plenty of data that is being captured and being used to do the modeling and things like that. Also, because companies or businesses are able to capture data, they have a lot more information about their customers. So there has been a trend in the business. That is, you can make a standard product and you can do mass marketing. And in that case, you have no idea who your customers are, but you are selling it to the masses. You're spending money on mass marketing, and you know the product that you're making is a standard product. Lots of people will use it. So that's how the business used to be many years ago. All right. But now one can think of niche marketing, one can think of customized marketing, one can think of database marketing by relying upon all the data that we are capturing and figuring out what kind of a niche product some people will like, and then target that to those people and things like that. So basically what has happened is, because of the data mining, there are new business opportunities that are out there, and businesses are exploiting them. And that's another reason why there is so much interest in this particular field, in this particular area. Here is a list of some of the typical applications of data mining. Market segmentation. How many of you are familiar with the term market segmentation? Yeah, I expected at least somebody from the School of Business will know. All right. So, as a business, what you want to look at is, okay, this is whole entire Metro Detroit is my market, and you want to segment that market into different segments. For example, the segmentation could be done based on geographic demographics of people living in different neighborhoods. There are neighborhoods where the median income is much high, house value is much high. So those neighborhoods are good targets for certain kind of marketing, certain kinds of products. On the other hand, there are neighborhoods where things are a little different. Maybe those neighborhoods are suitable for different kinds of products and things like that. Or maybe the auto manufacturers who are here, they want to sell cars, and I'm sure all of you have heard of the term soccer moms. All right, that's the term that was created to represent a segment of market for vehicle buyers. And the idea was that there are households where there are young kids, and those young kids are basically participating in the sports and things like that. So mom is driving them from one activity to another activity and so on. And what is the best vehicle for that? It was the Chrysler's minivan when they created it. And that's how that term got very popular. All right. So that's what the market segmentation is. Customer targeting and retention. Again, people are switching services left and right. So maybe, if you're running a company, you want to ensure that you retain your customers. So anytime you look at some issues cropping up, you want to make sure that you take care of the customers and retain them and things like that. So again, that's another activity. Product design and placement. When you go to a grocery store or any other business, the layout of the products and things like that is not arbitrary. It's not based on what the manager thinks. It's based on solid modeling. That is how people buy things, how they browse through things, and things of that kind. So again, the data mining comes in there, credit card fraud detection, web advertising, recommendation systems. These are all examples of data mining, or nowadays, these are all examples of machine learning. Okay. So if you look into any machine learning, that's what they're talking. So they're more or less the same thing. All right. Okay, let's see. Numerous applications. I just listed some of them. The stock market trends, text and multimedia data mining, sports scouting. Data mining or machine learning is very big in the sports nowadays, especially some of the teams on the West Coast, especially what's that basketball team from Oakland? Stephen Curry's team. They won the NBA championships a couple of times from Oakland. What's the name of the team? Yeah, Golden State Warriors. All right. That team is pretty big on data mining. If you read about them, you'll find that they have, I think a VP whose responsibility is all this. So number of other teams have seen the progress or how well that Golden State Warriors have done. So they have started copying them and using them. So it's a pretty big thing. Of course, medical field, it's pretty big. Scientific data analysis, very big, and all that. All right. So let's, with that, let's look at what kind of data are we talking. All right. So if you start looking at data, you will find you have structured data. What is structured data? That's basically data sitting in a database. Basically, the data consists of well-defined fields of numeric or alphanumeric values. Every field has a clear meaning. All right. So that is what we call as structured data. All right. Other than that, we do have. Other than structured data, the vast majority of data that's out there nowadays, and that is what is causing all the excitement and all the activities, is what we call as unstructured data. The unstructured data means the data has no well-defined fields of information, and such data requires extensive processing to get an idea of what is in that data. And if you want to look at the examples of unstructured data, basically blogs, tweets, news reports, pictures, videos, these are all examples of unstructured data. Because when you look at a tweet or a text document, there is no well-defined field where you can say, all right, this is what this field means. All right. So unstructured data requires a lot of pre-processing before it can be used for any of the data mining or model building operations. At the same time, this is the fastest growing segment of our data. And that's where a lot of interest, a lot of new work, a lot of new techniques are being created. And between these two, structured and unstructured, you can say we have something intermediate, which you can call as semi-structured data. Such semi-structured data has some kind of partial structure in it. And a good example will be, for example, medical reports, summaries of interviews or executive summaries, web documents, etc., where you have some well-defined thing. Okay, this is a summary, this is the medical conditions, and there are some pictures and all that. So there are things that have no ambiguity, and there are things which need certain interpretation. All right. So that is what we call as semi-structured data. All right. What are the core technologies if you were to build a data mining product from scratch? Essentially, you will need some expertise on database technology, because that's where you will be storing and getting your data ultimately. You will be making use of statistics. You will be making use of visualization so that you can visualize the data, get some understanding of what's going on. You will be making use of machine learning to build the models, and you will be making use of information retrieval so that you can organize and retrieve relevant information. So what we are going to be doing in this course is focusing on machine learning and information retrieval part. That is, we will talk about how to build different data mining models, which is pretty much same as how to build different machine learning models, and then how to represent text and multimedia documents, how to measure similarities between such documents, how to perform text processing, text similarity, text retrieval, and things of that nature. All right, any question anybody has? Okay, so let's look at what we call as the data mining process. That is, if you were to look at everything that's going to be involved in doing a data mining project from scratch, this is what you will be doing. You will start with domain understanding. That is, in what domain we are looking at. For example, you might be working in a medical domain, and obviously, if you have absolutely no understanding of the medical domain or whatever subdomain in the medical field that you're going to be working, obviously you will not be able to gauge the importance of different variables that you might have in your data, or you may not be able to realize the importance of the model that you might be making. All right. So it is very important for any given project to have a good domain understanding. Typically, what happens is that in a business environment, if you're working, you are not working alone, you are working in a team. So in that team, there might be somebody who has a strong knowledge on the business side of the work. That's the domain knowledge. And you have strong knowledge on the data mining, model building side. So two together can function as a good team. All right. So, but it's important that for any project to be successful, you need to have a reasonably good amount of domain understanding. All right. So once you have a good domain understanding, you might figure out what are the data items that are of importance for a given project. Because businesses typically have lots of data, all kinds of things. But you're not going to work with all of the data that they have. What you need to figure out is what are the data items that are more relevant, most important for your project at hand. So basically, you need to perform data selection. And again, that requires a decent amount of domain understanding. All right. Once you have figured out, okay, these are the data sets we are going to be using, then you need to go through a process which we call as cleaning and pre-processing. Because data is never clean. It's always full of errors, full of mistakes, full of missing items. So a considerable amount of effort goes into cleaning the data and getting it ready in a form and a format so that it can be used for model building. Now, based on the experience of lots of people and many studies that have been conducted, this particular stage, cleaning and pre-processing, typically takes about 60–70% of the overall effort that a data mining project takes. So if you're spending 100 hours on a data mining project, you will be basically spending about 60 hours on these parts. All right. So once you have cleaned the data, it has been pre-processed, it's in a form where you can use it. What you want to do is you can now use it for discovering relationships, discovering patterns that are present in the data. All right, so that is where the actual data mining operation or actual model building operation takes place. All right. Once you have built the model, you need to, of course, check for its accuracy, etc. But more important is you want to look for an interpretation for your model. That is, you want to figure out what is it that model is telling you, not in terms of the variables or the features or whatever it is, but what the model is telling you from a business perspective. How can you interpret that model to drive your business further up? Okay, that's a very important part. And finally, if you are happy with the interpretation and you're happy with the model, then you go to the reporting and implementation. I just said reporting, but typically it involves implementing it and putting it in the practice. And of course, once you do that, then there is an issue of maintaining it and things like that. So essentially, these are the different stages of the data mining process. And if you look at this picture, you will notice that all the arrows are bidirectional. It's not a linear one-directional process. There is back and forth. That means, which I mentioned earlier in the definition, it's an interactive, iterative process. That means you select certain data sets, and you try to build a model. And you find that model is not that great. And you think about it, and then you go back and get some more data about some other things that might be helpful for your model. All right. So that's what will happen with the arrow going backwards. Same thing for cleaning and pre-processing. You did few things, and maybe you need to do few more things. The model that you use or the technique that you use, maybe that is not the right technique. You want to use a different technique. So there is always a component of interactivity and iterativity. It is not one shot that you start from A and end up G, one very nice. You are always going back and forth to figure out things, to tune some parameters that might be involved in the process and things like that. All right. Any question? Okay. So basically, this slide shows you what we call as the virtuous cycle or virtuous circle of data mining. That is, if you are in a company and you are a champion of data mining, you might identify certain small project that will benefit the business, go through all these steps. And if you are successful, business will be happy and you'll get more projects. They'll apply it to more uh, activities and so on and so. All right. So let's look at now different stages that we talked about, one by one, at least some of the major issues before we get into the details of those stages. All right. So the domain understanding stage, there's not too much one can say except, without knowing the particular domain. But the basic idea here is to learn the business goals, because you're doing it for a company or an organization. So what are the goals of that organization and how this particular project will help them gather all the relevant prior knowledge that you might have, or you might ask around and try to gather that. And then, of course, it's best executed by the team of business and IT person. Obviously, you need some expertise from the business side. You need some expertise from the technical side. So put together a team, and that's how you will work on it. And the final point is good understanding of the domain avoids discovering irrelevant patterns or minimizes the chance for garbage in, garbage out. All right. And there are nice examples of garbage in, garbage out. One is butter in Bangladesh predicts the stock market. This is a study that was conducted about 25 years ago or something like that. And what somebody did is they took the S&P data and they took the Bangladesh butter production over a period of time and tried to build a model that is use the butter production to do the prediction of the stock market. And it was fairly successful prediction. But you can see that it doesn't really make sense. All right. So it's a kind of coincidence that happens, but you cannot really put your money on this. All right. So that's the kind of thing you need to avoid. Similarly, there was another study, I think correlation of Super Bowl wins by original NFL teams with positive returns for S&P 500, because NFL, again, at some point there were two, one was AFL and NFC and AFC, something like that. So basically somebody did some study on, what happens when original, I don't know which one is the original team, but when one set of team wins, what happens to S&P, and another set of team wins, what happens to S&P. So again, they found a decent correlation. Okay. So again, these are examples of garbage in, garbage out. What you want to do is you want to make use of data that contains relevant attributes, relevant features, relevant pieces of information, and use that to build your model. If you are trying to do a project, let us say, all right, you're not working for a company, you just want to, dabble and become experienced. Okay. So what are the data sources that you can look for, or you can go for? All right. So point of sales data, these are collected by companies. Obviously, you'll not be able to collect it, but some companies do put out some of that data. Especially, how many of you are familiar with Kaggle? Okay. K-A-G-L-E, Kaggle. Kaggle is a website. You can look for it. All right. They have basically the trend is that number of companies don't want to hire people. They don't want to pay them. They want to save money. So what they will do is, for example, Kroger, let us say, Kroger is interested in, let's say, building a point of sales model for some data mining application. All right. So they will collect, they'll collect lots of data, and a big chunk of data they will go and put it on Kaggle, and they will say, all right, here is the data. We are asking people to build a model to do the prediction or whatever it is. All right. And whosoever does a good job or great job, we give them $10,000 or $20,000 prize. All right. So instead of hiring in-house, what they are doing is they are outsourcing this data as well as what their project is. And there are a number of people. Now you might say, well, $20,000 is not a big chunk of money. Yes, it's not a big chunk of money in USA, but think of somebody who has a similar level of knowledge, but sitting in a country, let's say in Asia or in Africa, where $20,000 is a lot of money. So that person will spend a lot of time and do the project. And these companies will get that project more or less done. Then in-house, they can, polish it and make some changes, but they are getting a very good deal. All right. And of course, the person who is doing it also getting a good deal because they're getting a decent amount of money. At the same time, some of the people are doing it just to gain knowledge so that when you are looking for a job, you can say, well, I've done these 4 or 5 projects based on data that I got from Kaggle. All right. So that's a very good source for looking for data as well as looking for the projects that lots of people all over the world are doing and putting it up there. All right. So it's a very useful source. All right. So you'll find that many of these credit card charges, warranty claims, etc., of course, you'll get some data sets at Kaggle also. And of course, if a company doesn't want to, make use of that route, they will have in-house this kind of data, and they'll have some people working on it and doing their projects. All right. But these are, different ways in which businesses are collecting data, either for their own use, or some businesses are only in the business of data collection and they don't make use of it, except that they sell it to the other businesses or other people who might be interested in some of that data. All right. Data cleaning and pre-processing stage. So what do we need to think about here? So generally what happens is that the data comes from many sources, internal as well as external. So if you are a business organization, you have a lot of internal data that you are capturing or collecting. And there might be certain aspects of the data for your project that you don't have in-house, and you will go out and buy it. For example, a lot of companies will buy the demographic data for a particular geographic region if they want to run a campaign for that region. Because they typically don't maintain such data in the house. All right. So data is coming from many sources. And also, these sources could be using different formats, different forms of recording the data, storing the data. So you might have hierarchical databases, flat files, COBOL data sets, and whatnot. All right. So again, what you need to do is, if you're going to work with all that data coming from different platforms or different sources, you need to put it in one common format so that you can use that for your model building. So that will be part of pre-processing that you will be doing. And of course, data is never clean. There are always missing values, missing fields, errors, and things like that. And as I said, this is the most important stage. Typically, it consumes about 60 to 80% of total effort for a data mining project. Here are some examples of what kind of errors or things are present in the data. So if you look at, the people have done these studies, so they find that about 60% of the data is clean data. The rest of the data typically has some issues. For example, there might be duplicates. As an example, I get, or the errors in the names, etc. At home, I get, mailings with 6 or 7 different ways in which my name and things are spelled out. All right. I'm sure many of you have a similar experience. So there are missing last name. Sometimes there is a confusion of last name, first name. There are errors, missing emails, missing first name, all kinds of things, incorrect address, and so on and so forth. So there are all kinds of things that need to be corrected before your data becomes useful. All right. And of course, there are always outliers where somebody, especially if the data collection involves manual coding, for example, a lot of medical billing, etc., requires manual coding. They have to specify what code was used for this procedure so that they can bill it accordingly and all that. So sometimes, there might be mistakes in terms of what codes were assigned and things like that. Or somebody's age, if you're filling out, somebody might have filled an age, or for whatever reason, the error age shows up as 120 years, or it shows up as only 1 year or 5 years. So again, so these are all examples of outliers. One needs to figure out what are the outliers in our data, what are the normal range of values we expect, what are the values that are showing up outside, how do we correct them, how do we manage them, and things like that. So those are all part of pre-processing and data cleaning. All right. Data pre-processing. This step is known as data transformation. The idea here is to map data fields into representations that is more suitable for your data discovery stage. For example, when you are capturing data, you might be asking the date of birth. All right, so person has fill in their date of birth. All right. For your model, the date of birth really doesn't make much sense. You don't want to use that. What you want to use is a value that indicates what is the age of the person. All right, so what you want to do is you want to map that date of birth into an age. And sometimes you may not want to map into an exact age, 50 years and 9 months or something like that. What you might say is, all right, I'm going to divide the age into 4 or 5 groups. So young, adult, senior, very senior, whatever it is. All right. So that way you are mapping your date of birth into one of those categories. So that's an example of data transformation. All right. Customer addresses, instead of basically looking at the actual address and using that information in your model, you might basically integrate it to the zip code lab. So you might say, well, we're just going to treat every customer in a particular zip code with the zip code as a variable rather than the actual address. Or you might take it to the county level or the city level. So basically you can do it through some geographic means. All right. So these are all examples of data pre-processing. So once the data has been cleaned and it has been pre-processed, you can say, all right, now the data is ready for use in the pattern discovery stage. All right. So let's look at pattern discovery stage. There are 2 issues here, or 2 things that need to be decided. What kind of discovery model we want to use, because there are different models for discovering the relationships or patterns in your data. All right. So it's a question of what model to use. And then for every model, there are a number of different algorithms or different methods or different techniques. So you need to figure out what is the most suitable technique for that particular model. All right. So those are the 2 issues that need to be decided in the pattern discovery stage. So here is a list of discovery models that are popular. One is the association model, which is pretty much tied up with the recommendation model. And that's the example I showed you earlier. That is, if you want to watch a movie on Netflix and you click on a movie, and they might suggest, okay, this movie is good, but these are other movies which people have watched who watch this movie, you may like them. Or when you go to Amazon, they're suggesting you all kinds of things. So that's basically what the association or recommendation model is. Then there is a classification model. There is a clustering model, there is a regression model, sequential model, and sometimes you just make use of what we call as a visual model. That is, you basically visualize everything and use your own capacity to see what kind of relationships are there in the visualized information. All right. So we are going to look at some of these one by one. So the association model basically says 90% of customers who subscribe to at least 3 premium channels also subscribe to pay-per-view events, something like that. Okay, so that's basically is an example of association model. If you 50 or large number of customers who bought this also bought this, all right, or who went for a trip also did this, things of that nature. All right. This model is also known as market basket analysis because this model has its origin in modeling the grocery store behavior of customer purchases. What are the things that typically people buy together? Once you know what are the things that people buy together, then what you can do is you can either place them in a way that when they grab one, they'll grab the other thing without forgetting, or you might give them some coupons for one of the items, hoping that they'll buy the other item where you have a marked up price. All right, so you kind of make out your purchasing. So that's the reason this word originated, market basket analysis. And in general, it's known as the association model. All right. I already mentioned shelf management in the supermarket. That's where this model is used. Let's look at the classification model. All right. This model might look something like that. That is, if the annual income of the applicant is more than certain amount, the applicant is a homeowner, then the credit risk is medium, and maybe we can issue a credit card and approve a loan up to certain amount. All right. So that is the kind of model that a loan processing software or a loan processing app might use. All right. Or the model could take slightly different form. That is, it could calculate some kind of numeric value based on that formula that is shown in the second bullet. And based on that, do the approval. All right. Or sometimes you can have a model in the form of a tree structure where you go over different checks and figure out what action to take. All right. So that's basically a classification model. And here might be some examples. So in the data mining perspective, an application of classification model, one of the early applications was direct marketing. Nowadays, of course, you don't get that much of direct marketing in the mail. You might get it via email or via phone call. But at some point earlier, people used to get mailers in their mailbox. All right. So the idea was to reduce the cost of mailing by targeting a set of customers who are likely to respond to your mailer. So instead of sending out the mail to 1 million people, where each piece of mail might cost just a penny or 5 cents, you send it only to 100,000 people that you have identified through your classification model that most likely those are the good prospects for your product. So what you do is you save on your mailing costs and things like that. Of course, through email, etc., that's really not an important issue nowadays. But at some point, it was an important issue. And nowadays, of course, one can find similar situations where model like this will be of use. All right, so that's the model where we can make use of classification model. Fraud detection is another big application of classification model. So basically, the credit card company has to approve large purchases. So when they see a large purchase being taking place, they have to decide whether they should approve it or not, whether they think it's a fraudulent purchase or it's a real purchase. All right. So again, they have to use some kind of classification model to make a decision whether they should let the purchase go through or they should block the purchase. All right. So that's basically another application for this kind of model. Another model is what we call as a clustering model. Clustering model, so in the classification model, you are trying to classify a set of observations into one or the other category. All right, whether this purchase is a genuine purchase or it's a fraudulent purchase. All right. In the case of clustering, what you do is you have, let us say, a large collection of purchases. Each purchase, of course, obviously defined by or characterized by certain attributes. And what you want to do is, and you know that in that large collection, there are certain purchases that are not genuine purchases. All right. So what you want to do is you want to make use of some kind of clustering technique to group those purchases into 2 or 3 or 4 groups based on similarities of transactions. And once you have grouped them, then you can analyze each group and try to figure out whether entries in a particular group are fraudulent or valid or whatever it is. All right. So that's what we call as a clustering model. The idea is to do the grouping and then use that grouping to perform classification or whatever you want to do. All right. So it's similar to classification model, but there is no a priori information that's available for different classes. All right. So that's what we call as the clustering model. A big application of this clustering model is the market segmentation, which I mentioned right in the beginning. Basically, take a look at all the customers in the Metro Detroit area and try to put them into different subsets or into different groups based on some similarity measurement or some similarity metric. And then once the grouping is done, then you try to perform some kind of interpretations for those groups and then use that grouping and interpretation to, do whatever you want to do. For example, nowadays in the context of all these elections and all that, maybe the different political candidates or political parties, they might, they might have done this grouping and they have identified certain groups in which the people are likely to make donations. So those are the people in those groups are heavily then targeted. They get 1 or 2 or 5 emails every day asking for a donation. Okay. And some of us don't get because we are not part of that group. All right. So that's basically a way of doing market segmentation or voter segmentation in this particular case, and then using that information to help whatever is the underlying goal. All right. Document clustering. So You might have a large collection of tweets or large collection of documents, text documents, or even you can say musical documents. And what you want to do is you want to organize them into different categories. So one way is if you have 500,000 documents, you get a couple of people to read them, and then they'll tell you, okay, this deals with politics, this deals with the sports, this deals with finance. The other way is to have them in the electronic form and then send them to a clustering algorithm, and that clustering algorithm will then group the documents based on the similarity of their content, and then they will be grouped into 5 or 10 groups. And then you as a user can look at a group and say, oh, okay, this group basically is talking of all the financial things. This group is talking of all the documents that dealing with the sports and things like that. All right. So then you assign the names to those groups. The clustering algorithm doesn't know those names. It doesn't have access to those names. Okay, so that's the difference between clustering and classification. Any question? A regression model. In a regression model, you basically look for an output that is numerical in nature. So if you look at the classification model, the idea was you are looking at a purchase and you are classifying it whether it's a genuine purchase or it's a fraudulent purchase. All right. That means the outcomes are discrete. In the case of a regression model, the outcome is a number. And that number, depending upon what you're modeling, will have a range, lower range to the higher range, and output will be a number that will be in that particular range. All right. For example, here, just an arbitrary set of arbitrary model. That is, you are a power company and you want to make a prediction for what is going to be your peak load given the temperature and humidity, etc. So you might have a model something like this, which will basically produce, once you plug in those numbers, temperature, humidity, etc., this will give you a number which tells you what is the peak load. All right. And these numbers that I have here, for example, 300 plus 1.6 and temperature minus 65 h power 2, 2.4, relative humidity minus 80, etc. So these numbers 300, 1.6 and 2.4, these are the numbers that our model has discovered based on past historical record of temperature and humidity values for last year or last 5 years, and what was the corresponding peak load. So based on that data, we have been able to figure out that the first number, constant number, should be 300, the second number should be 1.6, and the third number should be 2.4. And if we have those numbers, then we get a very good prediction. All right. So that's how a regression model is going to look like. Sequential model is a little manipulation on association model, you can say. It basically says that, if certain event has taken place, then chances that something else is going to take place near future is predicted by the sequence model. All right. So for example, if you bought some tickets for the airline, chances are that you are likely to look for some hotel and car rental and things like that. So that's basically kind of sequential model. Visual model is where you basically try to visualize data using virtual reality or other sophisticated techniques where you can really blow the data up on a big screen in all walls and then try to figure out what's going on and things like. All right, so that's what we call as visual model. And there is an interesting visual model that I have, and you see some similar models every day when people are talking about, the heat index or, the voters or satisfaction, dissatisfaction with certain aspect. In this particular case, basically somebody did a study or a survey or collected data on what are the generic names for soft drinks all over the country in USA. So they found out that in different geographical areas, the same thing is referred by a different term. All right. So not everybody is calling it Coke. A lot of people call it soda, whatever it is. All right. So that's what is shown here in this kind of thing. All right. So that's a result of a visual model that somebody has created, and that can help you in understanding if you want. All right. Okay, let's see. So once the modeling is done, you need to come up with an interpretation. All right. Or you want to look at what is the quality of the discovered model or discovered pattern. All right. And there are two elements or two components of this interpretation. One is the quality of the model in terms of predictive accuracy. How good the model is able to do a prediction, for example, for the peak load. Does the prediction come close to the actual value or it is far away? All right. So that's basically measuring in some sense the accuracy of your model. All right. The second aspect is what is the value of this model to the business? Whatever you've discovered, can it be used to reduce the cost of doing business? Or can it be used to make more sales? Can it be used to improve the bottom line? All right, so that is the second element. And obviously, if you are a researcher in an academia trying to study and come up with new techniques for data mining of building models, bullet number one is what you will be concerned with. All right, you want to come up with a technique that can build highly accurate models. But if you are in a business, you might say, well, I'm willing to have a little inaccurate model. I don't care whether I get 95% accuracy or 92% accuracy, as long as the model gives me a way to make money or to reduce costs and things like that. All right. So there are different objectives depending upon who is looking at it and who is performing the interpretation. So basically, you can look at it from this perspective. You can say, all right, what is the value of mined information? And one way to measure this value is through what we call as the perceptive gap. That is, before you started this project, what kind of a view the management had about that data and the activities that are taking place in the organization related to whatever project you carried out. All right. And now that you have done a project, you have mined certain nuggets from the data. So the value or the perception of with this new patterns that you've uncovered, is there a big change in the perception of how things are by the management? If they say, oh yeah, this is pretty much known, so in that case, obviously it has no value or very little value. But if the management thinks, wow, that's cool, we didn't know that, we could do that. In that case, it has a big gap between what they perceived earlier and what they are getting now. So in that case, it's a very valuable model. The same thing in terms of dollars. So instead of, the view, you can say, all right, can they make use of your model to increase the gap in terms of the bottom line, make more money. Again, it is a valid model in that case. All right. So with that, once the interpretation is good and everybody is approved, then comes the next stage where you want to report, write up about the model, all the things you have done. And then, of course, you may not be deploying it. There might be somebody else in the organization that will deploy it. For example, nowadays the trend is that there are machine learning scientists who basically work on building the model. There are data engineers who will work on getting the data, cleaning, and all those kinds of things. Machine learning engineers mostly working on coming up with different models and things like that. And then there are people who are called ML Ops, which stands for machine learning operationalization. These are the people who will actually put your model into practice and maintain it. Because what happens in certain applications, there is a new data coming at regular intervals. That means you may need to update your model on a periodic basis. All right. Also, as I said, this is an iterative, interactive process. So sometimes, and there are a number of parameters involved. So sometimes you need to keep track of some of the different models that you have built with different parameters. All right. And again, these ML Ops people will basically keep track of all that, so that anytime you want to go back to some old model or some other models, you can always go back rather than again doing it from scratch. All right. So reporting doesn't mean just reporting, but it actually means implementing it, making it operational, maintaining it, and so on. All right. So what are the challenges? So I basically given you an idea of what are the different things that are involved. What are the challenges of data mining? Number one is scalability. When you look at different techniques, you will find that some techniques are pretty good when you are working with 1,000, 5,000, 10,000 examples, or a data set containing, that many records. On the other hand, there are techniques that are really good if you work with millions of records. All right. So whatever you are thinking of doing, whatever project you have, whatever algorithms you come up with or deploy, is it scalable? Can we scale it at a level where it is beneficial, it is useful? All right. So that's something that needs to be considered. Dimensionality. You are going to represent each purchase, let us say, by certain attributes. All right. The number of that, those attributes is what we call as the dimension. So typically, for industry applications, you are looking at 100, 200, 500 dimensions. And when you talk of that many dimensions, then there are issues related to what kind of training data you want, how much data you should have, so that you can work comfortably in a 500 dimensional space. So that's an issue of dimensionality. Complex and heterogeneous data. Obviously, you have you might be dealing with all kinds of data. There is a video, there is a set of PowerPoint slides, there are text documents, there are medical records and all that. So how do you deal with a variety of things for your work? All right. Data quality. How do you ensure that the data is of good quality, etc.? Nowadays, there's an issue of data ownership and distribution. Your data is being collected by different companies, or your medical record is being used by some company to build some medical products or devices. what kind of ownership you have on those resulting things. Who owns your data? So those are the issues that are involved. And of course, privacy. There are things, certain algorithms that can preserve the privacy of the people mentioned in the records. There are some algorithms that are not able to do that. So how do you ensure that you are working with techniques that allow you to preserve privacy and so on and so forth? So these are more or less different aspects of data mining. And I'm open to any question anybody has. Yes. Difference between?
Lower down and persistent down.
Oh, okay, the last one, all right. Oh, okay. Yeah, okay. This one?
Yeah.
Okay. Basically, you know, this is from a business perspective. So if you are an CEO or a manager, let us say, all right, running a particular group in your business, all right, you have as a manager certain idea of what your data that you're capturing tells you. Okay. And that idea is based on typically your experience. It's not based on, you know, sifting through the data, but generally it's based on, oh, this is how things are. This is how it happened. All right. But when you take that data and build a model, and that model tells something which is kind of new to the manager, then obviously the gap between what the model is telling and what the manager had preconceived notion, that gap is large. So if that gap is large, obviously the mind model has a lot more value. All right. Let me check with all those people on the Zoom. I don't know how they're doing. All right, let's see. Oh, your screen sharing is paused, stopped. No, okay, all right. All right, can you guys hear me?
Yes.
Yes.
Oh, no, that's not. Okay, that's the top. All right, let's, how do I? Oh, resume share. Wow. Okay. All right. Can you guys hear me? I can't get a feedback. So.
Yes, we can.
Yes.
Yes, Professor, we can hear.
Somebody said something in the chat.
Your speaker volume is low.
Oh, okay. Well, oh, the speaker volume is low.
Oh,
No,
You're
that,
getting your sound, I can tell that.
yeah. Are you able to log in? Are you looking?
I'm logged in,
Oh, okay. So it's coming in and all that.
it's coming in, I've got my speaker muted.
Oh, okay. That's
but I can see the microphone.
All right, all right,
Microphone's
okay.
on now.
no, it's literally-
okay. All right. All right. Can you do the chatting?
Oh, I don't want to do, oh, but what he's saying is your speaker output. So you may not hear them.
Oh, this one.
Yeah,
All right. Let's see. Where is
I
that?
think they're hearing you, but we're not hearing them.
it's not-
Well, I asked them in the beginning. They said they were able to hear me fine. All right. So that's fine. All right. And my only concern is whether this damn thing got recorded or not. So hopefully it got recorded because I did issue a record command. So we'll see. All right. Somebody did say volume good enough. Yeah, volume is good. Yes, professor. Okay. All right. Thank you. Okay. Very nice. All right, so basically, we have an option here. Either I can continue with the next topic, or we stop here. The reason is I just want to figure out all those things, everything is working nicely, then I have no problem lecturing for hours and hours and hours. We have done this many times. I'm just, concerned somebody might say, well, I didn't hear it, or it didn't get recorded, and this and that. So I just want, so far I didn't worry because the material we were talking was really not that important, but now it's an important material. All right. So I would rather stop here just to make sure what we did got recorded nicely, and then we move. All right. So thank you. But one thing I want to mention is please ask questions. I don't mind people asking me questions. And if you ask questions, and again, sometimes what happens is that you think, well, nobody else is asking, so I must be not getting it. Everybody else is getting it. But generally what happens is nobody is getting it. Okay, or maybe there is one person who is getting it. All right. So don't be afraid. No question is a stupid question. All right. So raise your hand, ask for explanations, and I'll be more than happy to explain things multiple times from multiple perspectives. I have no problem. Huh?
I'd like to ask a question.
Sure.
Suppose I am collecting a raw data, say group of people. Asian in Michigan state, or the average house value of Florida state. Which model should I be appropriate for in that case?
Come in. So that these people can also listen. I think they're still on Zoom. Zoom is still on, is that correct? I said I didn't turn off the Zoom, so it should. Okay. Can you repeat the question, please?
Okay. Suppose I am collecting the raw data.
Raw data about what?
About a group of people, to be very specifications, who lives in the Michigan state,
Okay.
or the price value, average price value of
The homes.
in homes in Florida state. Which of this model is suitable?
Okay.
Can I use the month, means more than 2 or 3 or?
Okay. Basically, if I understand you correctly, you are trying to build a model that will predict the value of a house.
Okay.
Okay.
Yes.
And of course, you want to limit yourself to a certain section of people, but your model could be used for everybody. It doesn't have to be, one particular group of people. All right. So say you want to build a model for predicting the house value. All right. Now, the model that you will be, or the technique that you will be using will be, or the discovery model that you will be using is the regression model, because your model output is a number. The model output is going to tell you that given the size of this house, number of rooms, when it was constructed, where it is located, what is the overall demographic information about that neighborhood. So based on all those attributes, it will come out with a number saying, okay, this house is worth $330,000. All right. Now, the same model will work for Florida also, because one of the attributes will be the state or the location of the property. So basically, you say, all right, this property is located in Florida. Then model will basically give you an output that will be valid for Florida. All right. Now, it's possible that given so much variation in the housing, state to state. I was in actually Los Angeles just 2 weeks ago, And I'm kind of getting to a stage where I want to retire. Okay, I've been doing teaching for 50 years. All right, so I want to retire. So, and my son lives there, so he doesn't want to move here. So I have to move there.
But we have water,
Huh?
but we have water.
Oh, yeah, I like it here, but you can't have, what can you do? All right. So I started looking at some properties. So the broker took me to a place. He said, it's nice property, 3 bedrooms, 2 bathrooms, and a decent sized lot, $1.2 million. I said, all right, let me take a look at it. Look at it. The whole property has to be demolished because it's in such a bad shape. But it's marketed or priced at $1.2 million, although it come down and might sell for about $900,000. But you wouldn't buy that here for $100,000. So there is a big difference from state to state, location to location. So if you want to build a model that will be applicable to a large area of United States, that model may not become very accurate because it may have difficulty in terms of coming up with close numbers based on the attributes that you decide. It's possible that if you expand your attributes and looking for a lot more attributes, then you can build a good model. The other action is to build a model location specific or geographically specific. For example, you can build a model for Oakland and Macomb County. All right. And that model will do a very good job. Similarly, you can build a model for Florida state, possibly, or for state of Florida, possibly will do it. But it will be a regression model because the output from the model is a number.
So is it possible we will use the classification model as such and whichever get the most?
No, you don't need actually a classification model in this particular case. All you need is a regression
So
model.
you're saying everything that comes under the numerical,
Anytime you want to get a numeric output, it's the regression model. Now, what you can say is, instead of predicting the actual cost or the value of the house, you might divide the values into the range, low range, medium range, high range. And you might say, well, the low range is up to 200,000, medium is 200 to 400, and high is 400 and above. So in that case, you are not predicting how much is the house value in the medium range. All you're saying is its value is somewhere between 200 to 400,000. So if you do that, then that's a classification. Okay, so you can do it, but doing it through classification in this particular case does not make much sense because unless you are willing to, have 10 or 20 different ranges, 0 to 100K, 100 to 150K, 150 to 200K. So in that case, it's too many cases. All right. Yes.
Building that, could you use multiple models?
Yes, you
Do an association model and then?
not that way, because each model has a different objective. But you could build 3 different regression models and then combine them to create a single output. For example, you might say, okay, you are one model, he's another model, he's another model. So you make a prediction that this house is worth 220,000. His model says 230,000. His model says 200,000. All right, what we can do is we can take the average of these 3 models. Or if my experience tells me that his model is always more accurate, then I can say, all right, I'm going to take the average, but I'm going to give 0.5 weight to his vote, 0.25 to his, and 0.25 to yours. So in that way, I'm taking into account his record into consideration. So it's always possible, and generally it is done, combining different models for the same purpose, gives you a better result. Okay, anything else? All right, then we stop here. Thank you very much. All right, you guys.
All right.
Mhm.